Hello friends, welcome back to Easy Math channel. In the last lecture we have seen the first law of exponent, that is called the product law, and we have seen a few examples. So we saw that when two numbers having same base with different powers and they are in product with each other, we can add their powers. We have seen some examples. Very quickly see the example. We saw that if we have x to the power 7 into x to the power 8, so we see that the base are same, we can simply add their powers. X to the power 7 plus 8, that is equal to x to the power 15. Now let us move to the next law, which is also called division law, in which we have two numbers with same base and they are in division of each other. So if there is a division, what we can do according to law, we have to subtract, or we can say we have to take the difference of the two powers. So let us see some example here. Again, we will take the same example, similar example as we seen previously. Let us take the example with some numbers base having some numeric values. So let us say we have 5 to the power 13, and that is divided by 5 to the power 7. Here we see that two numbers having same base y and they are divided with each other, and according to law, to simplify that, we simply have to subtract their powers. So that is equal to 5 to the power 13 minus 7, and 5 to the power 13 minus 7 is nothing but 5 to the power 6. We can also see another example in which we have some unknowns. Let us say we have p to the power 38 and that is divided by p to the power 30. So again we have same base p and we have different exponents and they are divided with each other. So according to law, it is nothing but 38 minus 30. So this would be equal to p to the power 8. Cool. Now let us move to the next law, which is also called power to the power, power of power. Now we can clearly see here we have a number with base a and there is a power m and there is another power n. So how we can simplify such kind of expression? According to law, we simply have to multiply those powers. Let us see an example. If I have 3 to the power 6 to the power 8, so what I can do here, I can see I have two powers. So according to law, I simply have to multiply those powers. That is 3 to the power 6 into 8, and 6 into 8 is 48. So 3 to the power 48. Let us see an example with some unknowns. Let us say I have q to the power 9 to the power 2, or let us take some negative power, say minus 2. So this would be equal to q to the power 9 into minus 2, and you very well know 9 into minus 2 is minus 18. As simple as that. You can also extend this law with multiple powers, not only two powers. Let us say, for example, you have a number m to the power 3 to the power 2, and you have one more power. Let us say you have 3 again. So according to the law, what you can do, you can multiply all powers, and that would be equal to, let me write down here, m to the power 3 into 2 into 3. So it is not like that you can only use for two powers. If you have multiple powers, you have to multiply all powers, and this would be equal to m to the power 18. Perfect. Now let us move to the next law, in which we see that we have two numbers, different numbers, and they have common power. So according to law, we can give power to both of them, a and b as well. So this will become a to the power m into b to the power m. Here the difference in the law is we have two numbers with different bases, a and b, and they have common power. So to understand this law, let us take one example. If I have 3 to the power 3 into 11 to the power 6. So what I can do, If I want to simplify this expression, I can give power to 3 as well, so it becomes 3 to the power 6 and it becomes 11 to the power 6. Such kind of law will be helpful in simplifying the expression in some upcoming examples we will see in the later videos. Let us take one more example with some unknown. So let us say if we have x into y to the power 2, so according to law we can give power 2 to x as well as 2 to power y. So this will become x square into y square, or x to the power 2 into y to the power 2. Similarly, if there is a division, we can still give power to both the numbers. That means 2 power, they are in division with each other. Sorry, 2 numbers, they are in division with each other, and here they have common power, so we can give power to both. Let us see an example. In the same way, let us say if you have 2 divided by 3 and you have some common power 6. So according to law, you can write the expression as 2 to the power 6 and 3 to the power 6. Some more example. Let us say if you have m divided by n and you have some common power, let us say 11, so you can write it as m to the power 11 divided by n to the power 11. So these are very simple and basic examples just to understand how we can apply this law. In the later upcoming videos, we will see some specific examples, some special example in which we will be applying these laws once or multiples, and we will see how we can easily use this law to simplify the expressions. Okay, the next law is a to the power 1 is equal to a. So this is a very standard law or very general law in which we have any number and we have power 1, so we can say that is equal to a. For example, the power law says if it is 5 raised to power 1, it is 5. If it is x raised to power 1, it is x. It is, let us say for example, if you have minus 2 to the power 1, it is minus 2. Okay, how we can say that any number to the power 1 is equal to 5? Let us take an example and understand how we can prove that. Okay, so let us say I have 5 to the power 6 divided by 5 to the power 5. Now I can simplify this expression by using law and without law. First of all, let us simplify this expression without using the laws. We very well know 5 to the power 6. What is 5 to the power 6? It is nothing but we have to multiply 5 6 times. Cool. And what is 5 to the power 5? This is nothing but 5 into 5 into 5 into 5. That is 5 is multiplied 5 times. Now you very well know you can cancel the common factor 5 with each other like this, and you are left with 1 5 that is equal to, you can say the final value for this will be 5. Now let us do this with the help of laws. We know that when two numbers are with the same base and they have different exponents and they are divided with each other, according to law you simply have to subtract their powers, correct? And that would be equal to 5 to the power 1. Now we already saw that this is nothing but equal to 5, so we can say that 5 to the power 1 is equal to 5. Perfect. Okay, so remember students, whenever you see any number to the power 1, that would be equal to that number. Now what if any number to the power 0? That will be equal to 1. We will also prove this. It's very simple. Okay, cool. Let us say we have a number, let us take some unknown this time, x to the power 7 divided by x to the power 7. Now students, you very well know x to the power 7 means x is multiplied 7 times. Perfect. One more, and again this is x multiplied by x I can say it is 7 times. Now you very well know you can cancel this. And if you cancel everything, you are left with 1. So this is nothing but equal to 1. Now let us do this example by using laws of exponent. Again, we know it's a division. We have same base. So according to laws of exponent, if there are two numbers with same base and they are divided by each other, we can simply subtract their powers. So both have power 7, so it is x to the power 7 minus 7, and 7 minus 7 is nothing but 0. But we already have evaluated this as 1, so this is nothing but 1. So we can say that, x to the power 0 is nothing but equal to 1. So any number to the power 0 will be equal to 1. Now let us go to the last and final law, in which we have the negative powers and we want to convert that negative power to the positive power, or negative exponent to positive exponent. So the law says if you have any number and you have negative exponent, you can convert that exponent to positive by just doing the reciprocal of that number. So a to the power minus n can be written as a positive expression as 1 to the power 1 divided by a to the power n, which is nothing but the reciprocal of a to the power minus n, or a to the power n. Let us see some example. Let us say if I have 2 to the power minus 3, and if I am asked, or it is required to write this exponent as positive, so not a problem, just do the reciprocal of that and your power will be positive. Perfect. Now based on this law, we can derive one expression, like for example, you have two numbers with different base and they are divided with each other. Let us say we have 2 by 3 and they have common power, let us say minus 3. Okay, so now again we can apply the same law and consider this as the single number. So what does the law states? If you want to convert this power as positive, just do the reciprocal of the base. So here the base is 2 by 3. So what is the reciprocal of 2 by 3? Reciprocal of 2 by 3 is 3 by 2, and you can write your power as positive. As simple as that. So students, we have seen all laws with some basic examples. So in next upcoming videos, we'll be going to very specific example and apply each law. Thank you.